we now need to distinguish reversible from irreversible processes, because then we have to understand how they're related. So first, let's think about our molecular collisions. These are reversible, and these are a great example of what we mean when we talk about reversibility. We have two molecules coming in that are going to collide and go off at an angle. And we can in fact assume that they're coming in at equal speed and they have the same mass, so they just deflect, but they go off with the same speed in the end. Now what we can do is play the movie backwards. So we're literally running it backwards. This means that they start at their final positions, but their velocity goes the other way. So again, it looks like they're aiming at each other, going backwards, but then again, they collide by deflecting, and then they're zooming off. The gray one is going to the left, and the orange one is going to the right. And if you look, this was our initial situation. So when you have an elastic collision, you can in fact play that backwards or forwards, right? Thinking about rewinding or fast forwarding a movie, basically. And it will look okay. The rules of physics work for an elastic collision whether you play that backwards or forwards. You can't actually tell the difference. It isn't like one of them actually looks wrong. So this is an important result. So we would say that this is a reversible process. You can stop it, you can run it backwards, and it will go back to its initial state. So what is an irreversible process? So not a microscopic thing, but something pretty simple to understand would be a car crash. That initially the car runs at a wall, and then it ends up hitting the wall, coming to a stop, and being broken. If I played this backwards, it would look wrong to you. You would see the pieces coming back up to the front of the car, right, reassembling, and then it zooming backwards. That would look wrong for many different reasons. And this is what we mean by an irreversible process. Basically, if you play the movie backwards, you know what you're seeing is wrong. So, simple definition. So let's go through some more examples and try to start seeing why we actually care about this. So the first example, which is a really nice example that there's many analogies to this, is stirring your cream into coffee. Now, if you don't drink coffee or you don't add cream to it, another example might be adding chocolate syrup to milk, adding honey to your oatmeal, adding butter to grits, whatever you want, but basically adding two substances together where you can clearly see the difference after they've mixed together, right? So if I stir cream into my coffee, initially I have my thick white cream and my very dark black coffee. I start mixing it together and I get a murky brown coffee. If I stir backwards, they don't separate back out. This is an irreversible process. I can't just stir the cream back out of my coffee. So if I play the video backwards, you know that you're seeing it backwards. It doesn't look right. So another example is shuffling a deck of cards. And this is getting closer to what we want to talk about. Imagine that I open a fresh deck of cards, and if you've never done this before, at least the brand I buy, it actually comes in order. So you have, for instance, 2, 2, 2, 2, one of each suit, and then, 3 of hearts, 3 of spades, 3 of clubs, 3 of diamonds, and so on. The cards are in order. I shuffle, and then the cards are all mixed up. So imagine there is a video of me shuffling the cards, and I am not a card shark. Obviously, there are magicians who can do this, but assume that it's me, very unmagical Dr. Ackerman. And imagine you're watching a video where you can actually see the cards. Now, initially, if they were all in order, you wouldn't be surprised. I could start that way. I shuffle them, they get mixed up, they get out of order. On the other hand, if you watched a video where the cards started completely out of order, and through what looked like random shuffling, they got back into order, you would be skeptical, right? You would be skeptical that I could do that, and you would assume that in fact I'm just playing the video backwards. And I'm going to come back to this example because I think this one's really helpful. So another, thermodynamics, is an ice cube melting in your tea. You get some tea at a restaurant that's, a little not cold enough, so you plop in an ice cube and you watch that ice cube melt. Again, you'd be really surprised if someone showed you a video of a glass of tea, suddenly an ice cube appearing in it and growing larger. You don't expect that to happen. So that is also an irreversible process. So why do we care about this? Well, in these cases, especially the second one, the individual things happening at the smallest scale are reversible. But in the end, we get an irreversible process. And that's going to be due to probabilities, which we'll talk about next. But let me give you an example specifically with the cards, right? Every time I shuffle the cards, I am making one random change, right? So one shuffle, right, is reversible. So why would that be? So think about, cards where, for simplicity's sake, I have 5 cards. 4 of them are 6s and 1 is a 7. I start with the 7 somewhere among the 6s, and in one shuffle, I basically pull my 7 and put it randomly into a different place among the 6s. If I was to play that video backwards, that would look fine, right? One motion of one card actually looks okay. But once you do it over and over and over again, and especially you start with a greater number of cards, with them in order, it's going to look irreversible in the end because of probability. So probability is going to be a little bit tricky. We'll talk about it in the next thing, but think about it this way, that if I have cards completely randomly arranged, there are many ways for those cards to be randomly arranged. For those cards to be perfectly in order, there's only one way that can happen. So whenever you think about these processes, we have to think about probability and then entropy, which is what we're talking about next.